Good morning, everybody. So we are going to discuss today the magnetic moment of electron, which is nothing but Dirac equation in electromagnetic field. So this is the last topic in this unit in relativistic quantum mechanics. Of course, we know about the concept of spin, which has evolved automatically from Dirac's Hamiltonian. So this is Dirac's Hamiltonian. And we know that C times Hamiltonian H equals C times alpha dot P plus beta MC square, where alpha and beta are 4/4 matrices. We know already. Alpha is connected with a Pauli spin as sigma x, sigma y, sigma z, and beta is the unit matrix. So we know about all those things. And alpha is connected with Pauli's matrices, just now I said, and this is about the concept of spin. So spin has evolved automatically in Dirac's Hamiltonian. That's a beauty. So now in this class we are going to apply magnetic field, electromagnetic field in Hamiltonian, in Dirac's Hamiltonian. So we know in the year 1921 when Stern and Gerlach performed a beautiful experiment to bring out the concept of spin. So spin up and spin down. After 4 years, 1925, it was fully explained by Uhlenbeck and Goldsmith. That's about H bar by 2. So plus H bar by 2 and minus H bar by 2 for the spin up and spin down. Similarly, we are also going to, today we are going to apply electromagnetic field. We are going to apply the magnetic field in the Hamiltonian through these two potentials. Ultimately, we are going to get the magnetic moment of the electron, which is connected with the external magnetic field B. This magnetic moment is connected with, associated with the spin. So this is a direct consequence of spin. At the end we are going to prove. So at the end we are going to have an expression. This expression, one of the expressions, it will say about the magnetic moment of the electron and magnetic field. So this will bring up the concept of spin. So this is what we are going to prove. So as I said, that we are going to apply these two potentials. One is a vector potential, another one is a scalar potential through the Hamiltonian. Okay, so P will be replaced by P minus EA by C. A is a vector potential, probably which you have studied. Okay, already in electromagnetic theory you would have studied EMT. So A is a vector potential and phi is a scalar potential. Okay, phi is a scalar potential. If it is multiplied with the charge, that will give you potential energy. So that's why E minus E phi. Both the units are correct. Both the units are the same. Where E is the energy, E phi is a potential energy, phi is a scalar potential. Okay, if you are going to differentiate with respect to R, d phi by dr will give you electric field. So E equals minus d phi by dr. Okay, E equals minus del phi. That is connected with the electric field, whereas E phi is connected with the energy, potential energy. Okay, so now we are going to apply vector potential and the scalar potential in the Hamiltonian. So we are going to replace P by P minus EA by C and E by E minus E phi. Okay, as I said just now that about the magnetic moment. Similarly, we can also have electric moment. So we can have both the expressions, electric moment as well magnetic moment. So very important thing is the magnetic moment of the electron, which will be interacted with the external magnetic field. That is the answer that we want. Okay. So with this introduction, we will look into this magnetic moment of the electron, which is nothing but Dirac equation in electromagnetic field. So we know that the relativistic relation between energy and the momentum of a free particle is given by this relation. So this is your energy and this will be momentum. And of course we know that Dirac Hamiltonian is given by this expression H psi equal to E psi. So we can write E psi equals this Hamiltonian. Okay, this Hamiltonian which acts on psi, which depends on R and T. Okay, so this equation can be written as, I am going to take this C inside. So this equation can be written as alpha dot Cp plus beta MC square, which operates on psi of R command. Okay, So I'm going to take this C inside, that's all. Okay, this equation can be written as 8.113. We know that the intrinsic magnetic moment. So spin is an intrinsic property of an electron. So intrinsic magnetic moment associated with the spin of the electron can be found in the following way. We are going to consider an electron in an electromagnetic field. We are going to apply electromagnetic field having a vector potential A and a scalar potential phi. Okay, so P is replaced by P minus EA by C, and the energy is replaced by E minus E phi. So Dirac equation and electromagnetic potential is given by, look at this equation, we have changed into E as E minus E phi, P as P minus EA by C. So P minus, as I said, P will be replaced by P minus EA by C. Okay, but earlier in the equation it is given as Cp. Okay, Cp is given. So what I have done is, your P equals P minus EA by C. So multiply on both sides will give you Cp. So here also Cp and C, P minus EA by C. Okay, is it okay? Now I will take LCM now. If I take the LCM, that will give you Cp minus EA by C. That C and this C will get cancelled. You have Cp equals Cp minus EA. Is it okay? I repeat. See, P equals P minus EA by C. I am going to multiply on both sides by C. So Cp equals C P minus EA by C. Take the LCM. So that will give you Cp minus EA by C. That C and this C will get cancelled. You have Cp minus EA. So Cp can be replaced with Cp minus EA. So Cp is replaced with Cp minus EA. Very simple. And of course, as I said, E is replaced with E minus E phi. I am going to bring all the term this side, and we can make this equation as a homogeneous equation. Very simple one. So we have now this equation 8.115 simplified form, and this is known as Dirac equation in electromagnetic field. So this equation is known as Dirac's equation in electromagnetic field. Suppose if there is no electromagnetic field, suppose we consider, and this part will not be there, this part will not be there. So we will have the original one. Okay. So now we are going to multiply equation 8.115 by plus factor. I am going to multiply this with, just change into plus sign. Just change into plus sign. I am going to multiply this equation with this equation. Is it okay? Just change this one. Minus into plus. Minus into plus. You make this equation, the expression. You multiply these two. So that will give you E minus E phi plus alpha dot Cp minus EA, okay, plus beta m squared multiplied by this. I have taken minus common out. So that will give you minus this. Is it okay? Any doubt? So we have now two terms on this side, we have two terms on this side. We are going to multiply, you will get four terms, correct? So you are going to multiply this term with this term. Okay, first one, and this term with, first this term with this one, and this term with this one. So we will have, how many terms we will have? This term with this term, and this term with this term. So we will have two terms, correct? And this term with E minus E phi. Okay, now this term with this one, this term with this one. The next one will be this term with this one, and this term with this one. So we'll have four terms. So 1, 2, 3, 4. Is it okay? Very simple. I repeat. So you are going to multiply these two expressions. So this term with this term. So first term. This term with this term. Second term. This term with this term. Third term. And this term with this term. So fourth term. So four terms are there. Simple idea. So when you are going to multiply first two terms, that will give you E minus E phi whole square. The next one will be this term with this one. So you will have minus sign, E minus E phi, this term alpha dot Cp minus EA plus beta m square. The next one will be multiply this with this term. So this will give you this expression multiplied by E minus E phi. Then the last one will be this term multiplied by this term. So you have minus sign. So I have written minus sign here. This term multiplied by this term, which is equal to 0. Okay, very simple. Now just you are going to multiply this term with this term, next step, and this term with this term. So we will have two terms. Next, you are going to multiply this term with this term and this term with this term. So 2 plus 2, 4 terms. Next one will be this term you are going to multiply with this term, and this term you are going to multiply with this term, 6 terms. This term you are going to multiply with this term, and this term you are going to multiply with this term. So totally 4 plus 4, 8, remaining 1. So totally we must have 9 terms. Is it okay? Very good. Is it okay? Very simple one. So we will have now 9 terms. You count it: 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9 terms are there. So look at the term first. First this term, let it be like this. You have the same term. The next one will be multiply this term with this term. So we have multiplied this term with this term. Is it okay? The next one will be multiplying this term with this term. So this term you have. So first two terms are over. The next one will be you are going to multiply this with this. Okay, so this with this. The next one will be multiply this term with this term. So we will have this term. Then the next one will be multiplying this term with this term will give you square term. The same term exists. So you are going to have a square term. The next one will be this term with beta mc square. This term with beta mc square. Then the next one will be beta mc squared with this term. One minus is there. Okay, one minus is there. So minus beta squared with this term. See, minus beta squared with this term. Then the last one will be beta mc squared multiplied by beta mc squared with a minus sign. So minus beta squared m squared c power 4. Simple. Is it okay? Any doubt? Now you will have to remember small ideas. Very important thing is in Dirac's Hamiltonian, the main concept which we learned was alpha and beta. So Dirac's Hamiltonian, we know that alpha and beta, they are all matrices. Matrices will anti-commute with each other. So remember, the first rule is matrices will anti-commute. So alpha and beta will anti-commute. What does it mean? It means that alpha beta which is equal to minus beta alpha. So you remember this point. It's very first rule. So alpha and beta will anti-commute. Dirac's Hamiltonian. So they are all matrices. So your alpha beta is equal to minus beta alpha. All the other quantities will commute with each other. You remember this. The first rule is alpha and beta will anti-commute. Second rule is all the other factors in the sense alpha with P, alpha with E, beta with E, beta with P, as well phi with beta. So all the other factors will commute. You just remember this rule. That's all. All the other things are very simplified. So we can get the expressions easily. Okay. So E minus E phi beta mc squared. Okay. Just now I said EB will commute with each other. That means E beta equals beta E. So I can write this as beta mc squared E minus E phi. Correct? This expression can be written as beta mc squared. Mc squared is a number. I can take it anywhere, but not operators. But we know that E beta can be written as beta E. So I can pull this beta in front. So beta mc squared E minus E phi. Look at this one. Both are the same. So we can cancel it out. Is it okay? Is it okay? See, I can pull this beta this side because E beta equals beta E. mc squared is a number. I can take it anywhere. So this becomes beta mc squared E minus E phi, which is exactly with the opposite sign of these two expressions. So both will get cancelled. The first point is over. Next one is beta squared. Beta squared equals 1. Alpha squared, alpha x squared, alpha y squared, alpha z squared, all will be equal to 1. We have already learnt. So beta squared equals 1 means this will become your m squared c power 4. I have brought m squared c power 4 front. So this equation becomes e minus e pi whole squared minus m squared c power 4. Is it okay? First two terms I have already discussed. Okay, is it okay? Any doubt? Now just take this term. Okay, you are going to take this term. P and beta, they will commute with each other. So I can bring this beta front. I repeat, P and beta will commute. I can write P beta equals beta P. So I can take this beta here, not in front of beta, not in front of alpha. Okay, is it okay? Is it clear? Not in front of alpha. After alpha only I can put it. So this becomes alpha beta Cp minus Ea mc squared. Is it okay? This one I have written the same thing. I have written the same thing as beta alpha mc squared Cp minus Ea. Is it okay? Come on, these two terms. I can shake it off these two terms. Why? Alpha beta equals minus beta alpha. So this becomes plus beta alpha. So we can take it off. So this term is over, this term is over, and this term, these two terms are over. Now we are going to multiply this term with this one. Okay, we are going to multiply this term with this one. So multiplying this will give you E alpha Cp with a minus sign. This term. I repeat, minus E is here. E alpha Cp. See, minus, I can write this as C E alpha dot P. Next term will be this term. So minus E alpha minus, one minus is there. So this becomes plus. So we have E alpha Ea. See, E capital E alpha dot A. So this term is over. Is it okay? The next term will be minus into minus plus. So E phi alpha Cp. Minus into minus plus. So minus E phi. Okay, here it is. Minus E phi, minus plus E phi alpha Cp. See, E phi alpha Cp. This term. The next one will be this term, and this term. Already one minus is there. Minus plus. Plus into minus. So you have already E multiplied by E squared. So you have phi alpha dot A. Is it okay? This term is over. Any doubt? So up to here we have finished. Okay. Now we will go for this term. So this term will be, you will get E alpha Cp. So E alpha dot P. See, I repeat, alpha dot Cp E. So C alpha dot P. C can be written anywhere. Doesn't matter. It's a value. So we can write it. The next one will be. So we have finished this and this. Okay. Next one will be your alpha Ea E. So minus E alpha dot Ae. Okay. The next one will be this term with this term and this term with this term. This term with this term will give you minus C E. Okay, alpha dot P phi. Then the last term will be, you are going to multiply this one. Alpha Ea E phi will give you minus plus. So plus E squared alpha dot A phi. And we have written the same. Any doubt? Very simple. But you have to be more careful. So this acts on psi will give you 0. So this is the thing I said, that alpha and beta will anti-commute. All the other things will commute. So alpha E minus E alpha equal to 0. Beta E equals E beta. Alpha P equals P alpha. Beta P equals P beta. And of course we know beta squared equal to 1 and all the other things. Now we are going to simplify this equation. As I said earlier, these two terms will get cancelled. We are going to write the first term, the second term. Now we will go for circle term, these two terms. So you have minus C alpha, you can write this as minus C alpha EP, correct? This term can be written as minus C alpha EP because of commutation relation. E alpha can be written as alpha E. So minus E alpha EP. You write as it is like this. Okay, this term, these two terms are over. Now you will go for this term. This term can be written as E alpha can be written as alpha E. They will commute with each other. So plus E alpha EA. Okay, EA. You write this term exactly as it is. Now we will go for these two terms. So you have plus EC phi alpha can be written as alpha phi. See alpha phi P. Then this term you write it as it is. Is it okay? Next term you are going to write this as phi alpha can be written as alpha phi. And this term will be, you write it as it is. The last term let it be like this. Now you can cancel these two terms out. You can cancel this term and this term out. So now you have this term. Okay, you are going to combine these two terms. See E alpha EA minus E alpha AE. So you can take some common terms out. So we are going to combine these two. So first term, this is second term. You are going to combine these two, third term. You are going to combine these two, fourth term. This term will already straight. So we have only this term. So we have 5 terms. So now combining these two terms will give you E alpha EA minus AE. Combining these two terms will give you common terms out. That will give you the next one. See phi p minus p pi. So this one will be phi p minus p pi. So as I said, there will be 5 terms. 1, 2, 3, 4, 5. See, simple one.